We are told that f of x is equal to all of this. Identify when f of x is greater than or equal to 0. So pause this video and have a go at that before we do this together. All right, so what we're going to be doing is thinking about all of the places where f of x could be equal to 0, and then also the places where f of x has a vertical asymptote, and those are all possible sign transition places, and some of them might even be included because this is not just greater than 0, this is greater than or equal to 0, and then we can test the intervals in between to see what's actually going on. So when does f of x equal 0? Well, that's if either of these expressions that we see up here, either of these expressions are equal to 0. So that first one, if that's equal to 0, that means x equals 3. This second one, if x plus 2 is equal to 0, that means that x is equal to negative 2. So these are both interesting values. They're definitely places that we would include in the solution because the function is equal to 0 at both of these points. But also let's think about where we might hit vertical asymptotes. So that's when the denominator is equal to 0. So for example, let's look at when 2x plus 1 is equal to 0. 2x plus 1 is equal to 0. That means 2x is equal to negative 1. That means x is equal to negative 1/2. And then last but not least, we could look at when x minus 5 is equal to 0. X minus 5 is equal to 0, or it's at x equals 5. All right, so let's think about, I will just draw these out on a number line, and we can maybe think about what we want to include or not include. So we go from negative 2 all the way up to 5. So maybe if this is 0, let's see, we go 1, 2, 3, 4, 5, and negative 1, 2, 3, 4, 5. And so if we're thinking about, let's see, negative 2 right over here. So that is negative 2. That's that first point, or one of the first points. It's the lowest of the points. And then we go to x equals negative 1/2, which is right over here. Negative 1/2. And actually, I'm going to make sure that we don't include that point. So actually, I'm not even going to fill it in. I'm going to put an open circle there. That'll help us. So negative 1/2. But that is a place where we might see some type of a sign switch. We will include x equals negative 2 because that's a place where the function is equal to 0. So it's nice that I filled that point in. And then next we go to x equals 3. That's also another point where the function is equals 0. So I'll include that. 1, 2, 3. So x equals 3. And then last but not least, I have x equals 5, but we can't include it because that's actually a restriction to the domain. It makes the denominator equal 0, so that's 5. So let's think about when we're greater than 0. So let's try out negative 3 right over here. Let me do these in neutral colors, actually. So let's try this point, negative 3. So if I were to try that out, f of negative 3 is equal to negative 3 minus 3 times negative 3 plus 2, all of that over 2 times negative 3, which is negative 6 plus 1 times negative 3 minus 5. And really all we care is the sign, whether we are greater than or less than 0. So this is going to be negative 6 times negative 1. So our numerator is going to be positive in this situation. And then this is going to be negative 5. And then this is going to be negative 8. So our numerator is going to be positive. It's going to a negative times a negative. And our denominator is going to be positive. So this is going to be a positive value. And we're assuming we're not going to have any more sign switches if we go to the left of negative 2. So I'm going to include all of that when we are greater, saying that we are going to be greater than 0 here. So I'm going to include all of this in our solution set. And let's see what's happening in between here. So let's try at negative 1. So f of negative 1 is equal to negative 1 minus 3 times negative 1 plus 2, all of that over 2 times negative 1, that's negative 2 plus 1 times negative 2 minus 5. Our denominator, let's see, this is a negative. It's a negative 1. This is a negative 7. Our denominator is still positive, but our numerator over here is now, this is going to be negative 4, while this is going to be positive 1. So our numerator is now negative. A negative over positive, this is a negative. So we're going to be less than 0 here. So let's exclude this interval. This interval right over here, we're going to exclude it. Now let's go to this section, and a number that's always fun to test out is 0. The math tends to be pretty straightforward. So let's see, f of 0 is going to be negative 3 times 2 over 1 times negative 5. And so that is equal to negative 6 over negative 5, which is equal to positive 6 over 5. So I'm feeling pretty good. I'm going to shade that in the green again. So this interval right over here, because I don't expect any sign changes. And we know that 3 is also included because that's where we equal 0. Now let me try out 4, see what's going on there. I'm guessing that we might have a sign switch and this might not work. But let's try f of 0. F of 4, I should say. F of 4 is going to be 4 minus 3, which is 1, times 4 plus 2, which is 6, over 2 times 4, which is 8, plus 1, which is 9, and then 4 minus 5 is negative 1. So it's going to be a positive over negative. So this is less than 0. Yep, this interval doesn't count. But now let's go to values larger than 5, and let's try 6. So let's try, let me do this in a color I have not used. Well, I'll stay neutral. F of 6 is going to be 6 minus 3, which is 3, times 6 plus 2, which is 8, over 12 plus 1, which is 13, and 6 minus 5, which is 1. So everything here is positive, so this checks out. So I think we have our interval now. Our interval, we can go from, let me just write it, I'll write it in a neutral color. We can go from negative infinity, and we're going to include up to and including negative 2. And then to that, we are going to add, we're not going to include negative 1/2, because our domain is restricted there. That's a vertical asymptote. All the way to and including 3. And then to that, we're going to also add, if we're thinking about all of the intervals that work, we're going to go from 5 to positive infinity. And we are done.